Good day, Springford. This is Mrs. Smith. Today we will be going over Grade 6, Chapter 10, Volume and Surface Area, Lesson 1, Volume of Rectangular Prisms, Independent Practice Pages 743 and 744. Find the volume of each prism. The formula for the volume of a prism is the area of the base, which we indicate with a big B right here, times the height. Now our base, which is the bottom of our shape, happens to be a rectangle. So to find the area of the base, I need to use the formula for the area of a rectangle, which is simply length times width. Now I'm going to bring down the rest of my formula. So for the volume of a rectangular prism, I'm going to have length times width times height. So I'm going to have volume equals, and in this case, it doesn't really matter which one we use for length or width. I'm going to say that my length is 10 meters times 4 2/5 meters, and my height is going to be 3 meters. We can use the commutative property to multiply 10 times 3 first, which gives us 30 meters squared times 4 2/5 meters. Now just so that you know, 2/5 equals 4/10, because 2 divided by 5 is 4/10. So on your calculator, you can do 30 times 4.4 equals, and you're going to get a volume, and my marker's so tiny here, volume equals 132, now this is meters squared times meters, and that's meters cubed. So we have 132 meters cubed. Now why is it meters cubed? This is because we have 3 dimensions: length, width, and height. Remember, meters is just one dimension, and that's perimeter. Meters squared is area, and that's perimeter. Area, which is length times width. And then meters cubed is volume, and that's length, width, and height. So it all depends on how many dimensions you're using to calculate what you're calculating, perimeter, area, or volume. Question number 2, we're finding the volume of a rectangular prism. The formula is volume equals area of the base times the height. Our base is a rectangle, so we're going to use the formula for the area of a rectangle, which is length times width. So volume is going to equal length times width times height. So volume will equal 5 yards times 10 yards times 12 3/8 yards. 3/8 equals 0.375 as a decimal. So in your calculator, you can write 12.375. So volume equals 5 times 10 is 50, and yards times yards is yards squared, times 12.375 yards. And when you multiply those numbers together, you get 618.75. We have yards squared times yard is yards cubed. We're doing the volume of a rectangular prism. So volume equals area of the base times the height. Our base is a rectangle, so we're going to use length times width. So we have volume equals 6 inches times, now do you see how this is 6 inches here? So this is basically 6 inches here as well. 6 inches times 4 3/4 inches. Now 3/4 can be written as 0.75, so you can write the number as 4 7/75. 6 times 6 is 36. Inches times inches is inches squared times 4.75 inches. And when you multiply these numbers together, you get 171 inches cubed. Now we've been using, I'm just noticing now, we've been using dots, but now that I'm actually using decimal points, I might move to X's. It's just a preference. When you're doing algebra, you want to use dots, but then sometimes, you know, if you're doing a lot of work with decimals, maybe you don't want to use dots. So that's why it's interchangeable. So you use either a dot or an X, whichever one you think is best. Question 4. A fishing tackle box is 13 inches long, 6.5 inches wide, and 2.5 inches high. What is the volume of the tackle box? So I went and found a tackle box for us to visualize this problem better. However, it does not really fit the dimensions well, because this is actually a very flat box. It's only 2.5 inches high, and as you can see, our box is a little bit taller than that. So I went out and I thought, oh, let me see if I can find a different one. And this tackle box would be more fitting for our description, because as you can see, this would be probably 2.5 inches there. So that would be a height of 2.5 inches. And then this would be a width of 6 inches wide, and then 13 inches long. And we have our formula, volume equals area of the base times the height, and we have a rectangle, so it is length times width. So our volume is going to equal 13 inches times 6 inches times 2.5 inches. 2.5 can be written as 2.5 on your calculator. So volume equals 13 times 6 is 78 inches squared times 2.5 inches. And when we multiply those together, we get 195 inches cubed. And there you go. Question 5. Find the length of a rectangular prism having a volume of 2,830.5 cubic meters, a width of 18.5 meters, and a height of 9 meters. Now, I do like to draw pictures, okay? So I'm going to draw a rectangular prism, and forgive me because I'm drawing on a pad here. So a prism, we double the shape. Okay, so I drew that, and then I'm going to double it. So I draw the same thing again, and top left to top left, bottom left to bottom left, top right to top right, bottom right to bottom right. Okay, and there's my prism. So what do I know? I know that this is, I'm going to change my color, this is 18.5 meters, and the height is 9 meters. I don't know the width, so this I do not know. But I know the volume equals 2,830.5 meters cubed. So we're going to plug what we do know in, okay? So we know the volume, so that's 2,830.5 meters cubed equals, and then we have 18.5 meters times, we don't know the width, and we do know the height is 9 meters. So I'm going to multiply 9 times 18.5. 9 times 18.5 equals 166.5 meters squared. And then I'm just going to bring this number down. Now, a good time to talk about handwriting. Being neat is super important, okay? Make sure your commas look like commas and your decimal points look like decimal points, all right? Now, I also have to bring down this W because that's what we're solving for. Okay, now I'm going to divide by 166.5 meters squared, 166.5 meters squared. All right, so on the right, that cancels each other out, and I just have W left. So I'm going to write W. And on your calculator, it's 2830.5 divided by 166.5 equals, and surprisingly enough, we got a whole number, 17. And now let's take a look at our units. Okay, we had, I'm going to draw a little arrow over here. We have meters cubed over meters squared. So that would be meters times meters times meters over meters times meters. So we cross off, and that leaves me with just meters, which is true because width is just one dimension width. So the width is 17 meters. Find the missing dimension of each prism. In this case, again, we have a rectangular prism, so we're going to use the base the area of a base, which is length times width. And we know from our diagram that the volume is 60 inches cubed. We do not know the length. We know that the width is 2.5 inches. And the height is 4 inches. Now, do you see how my L looks like a 1? That's why in math they use cursive. So it should look like that more so. Make it look like an L. Okay? So we're going to multiply 2.5 times 4. And we get 10. So we have 60 inches cubed equals the length times 10 inches squared. Now we're going to divide by 10 inches squared. 10 inches squared. This cancels out on the right, which just leaves me with L for length. And 60 divided by 10 equals 6. And inches cubed over inches squared is inches times inches times inches over inches times inches. So they cancel out and it just leaves me with inches. So our answer is the length is 6 inches. Question 7, find the missing dimension of each prism. So we have volume of the area of the base times the height. Our base is a rectangle. So we're going to use the formula for the area of a rectangle. Our volume is 109 1/5 millimeters cubed. Now we're going to write this as a fraction as a decimal. 1/5 equals 1 divided by 5, which is 2/10. Okay, so I can write this as 109.2 millimeters cubed. Okay, and that's easier to type into your calculator. So that's nice when you don't have a calculator that has fractions. All right, the length is 7 millimeters. The width we don't know. And the height is 5 1/5. Now we already said that 1/5 was 2/10, so I can just write 5.2 millimeters. Okay, so 7 times 5.2 equals 36.4 millimeters squared times the width equals 109.2 millimeters squared. And now we're going to divide both sides by 36.4 millimeters squared. And look, do you see how I made a mistake right here? I wrote a 2 instead of a 3. As you get older and you get into algebra, you have to really be careful. And little mistakes like that can mess you up in the long run. So they're just little tiny human errors that can get your problem incorrect. So you have to be very careful. All right, so now we have 109.2 divided by 36.4 equals 3. Would have never guessed that would be 3. And millimeters cubed divided by millimeters squared is just millimeters, okay? And I'm not going to draw that out. Hopefully at this point you know. All right, there we go. All right, question 8. Be precise. In Japan, farmers have created watermelons in the shape of rectangular prisms. Find the volume of a prism-shaped watermelon in cubic inches if its length is 10 inches, its width is 2/3 of a foot, and its height is 9 inches. So now, in Japan, they have some farmers, they create watermelons in the shape of rectangular prisms. So I went online and got you a picture of what that would look like. All right, so here are some rectangular prism watermelons. So basically they get a plastic mold, and as the watermelon grows, it fills the mold. And they actually have heart molds and they have triangular pyramid molds as well. And they're kind of a specialty item. So it makes it a little bit more fun to purchase. Now, the watermelons that they're talking about in our problem are 10 inches by 2/3 of a foot by 9 inches. And if you look carefully, 2 of our dimensions are in inches and 1 is in a foot. Now, before we multiply these numbers together, they have to be all the same unit. So since 2 of them are inches, we're going to change the third one to inches. So I have a ruler here, and since it's 2/3 of a foot, I'm going to divide my ruler into thirds. So since it's 12 inches in a foot, I'm going to divide 12 into thirds. So that would be 4 inches and then 8. Okay, so every 4 inches is a third. So this is 1/3, 1/3, and 1/3. So 2/3 would be 1, 2, 2/3 is 8 inches. So that's going to be 8 inches. Okay, so for our watermelon, we can say that it's 9 inches by 10 inches, and then over here we'll say it's 8 inches. So it's almost roughly like a square, but it's a rectangle. All right, so here's our formula. So volume is going to be 10 inches times 9 inches times 8 inches. So volume equals 10 inches, and I'm going to multiply these two numbers first. 72 inches squared, and then the volume equals 720 inches cubed. And there you go. Question 9. The glass container shown is filled to a height of 2 25/100 inches. A. How much sand is currently in the container? B. How much more sand could the container hold before it overflows? C. What percent of the container is filled with sand? Well, let's take a look at this container. As you can see, the entire container is not quite filled. There's a little bit of a gap at the top, and I'm going to draw where this gap is. So we have a little bit of a gap here. You can see that. All right. Now, this tells me that the sand goes up 2 1/4 inches up. So from here down to here is 2.25 inches. So what would this right here be? So we have to take 3 inches, subtract 2.25 5 inches. So we're going to subtract. So that's 570. All right, so right here, this little gap is 75 hundredths of an inch. Now, both of my numbers are in decimals, so I'm going to change 4.5 inches also into a decimal, so I'm working all with decimals. Now I have all the measurements that I need to solve my problem. So for A, it says how much sand is currently in the container. So we have our formula, and we're going to have volume equals the length, 5 inches, times the width, 4.5 inches, times the height. Now the sand is only 2.25 inches. 2.25 inches. Okay, so the volume is going to equal, if I multiply 5 times 4.5, I get 22.5 inches squared times 2.25 inches. And so my volume equals 50.625 inches cubed. All right, so that's A. So, sorry, 50.625 inches cubed. All right, now as a fraction, that's going to look like that. All right, next, B, I'll change my color so we can see it a little bit differently. B, how much more sand could the container hold before it overflows? So that would be how much could be in this little empty space. So now we have the volume equals, we still have the same length and we still have the same width, okay, but it's up here, length and width. All right, so that's still 5 inches times 4.5 inches times, but this time the height is going to be 0.75 inches. So our volume is going to equal 22.5 inches squared times 0.75 inches. So our volume is going to equal 16.875 inches cubed. So that's how much could fit in that little gap. All right, and I'm going to write this here, 16.875 inches cubed. And as a fraction, it would look like that. Now, right, we'll go with purple. What percent of the container is filled with sand? Now to figure out this, I need to know how much sand would be in the container if the container was completely filled. Okay, so let's pretend the container was completely filled. So we're going to multiply as if it was completely filled. All right. So now we have volume equals 5 inches times 4.5 inches times 3 inches. So volume equals 22.5 inches squared times 3 inches. So volume equals 67.5 inches cubed. Okay, so 60, all right, so now, let me get my highlighter here. Well, actually, I'm going to change colors. So the question is asking for the percent of the container that's filled with sand. So we're going to make a ratio, sand, and then like in all, because that's a percent, okay? So what can the container hold? The container can hold 67.5 inches cubed. how much sand is in there, that's this amount, 50.625 inches cubed. So we're going to have to divide. So if you divide 50 and 625 thousandths by 67.5, you're going to get 0.75. And remember, you move the decimal point over twice, and that gives you 75%. So that's 75%. Now, I do have to tell you that I don't really think that this picture looks like 75%, because that's 3/4, and the picture kind of looks like more than 3/4, but I guess it really is 3/4. I don't know. I guess it is. But anyhow, maybe it's not drawn to scale. But there's the math, and there you have it, and we're all done this problem. Moving on. Question 10. Identify structure. Refer to the graphic novel frame below for exercises A through C. A. Pillar chose the box on the left. If it is 8 inches long, 8 inches wide, and 8 inches tall, what is the volume of Pillar's box? B. Amanda chose the box on the right. If it is 8 inches long, 6 inches wide, and 10 inches tall, what is the volume of Amanda's box? C. Who received more popcorn, Pillar or Amanda? How much more? All right, we're going to find Pillar's volume of her popcorn box first. And it is 8 inches by 8 inches by 8 inches. So we have volume equals 8 inches times 8 inches times 8 inches. So the volume equals 64 inches squared times 8 inches. So the total volume equals 512 inches cubed. Now we are going to calculate Amanda's box. It is 8 inches by 6 inches by 10 inches. So we have volume equals 8 inches times 6 inches times 10 inches. So the volume equals 48 inches squared times 10 inches for a total of 480 inches cubed. So now we need to see who had the most, and that would be Pillar, because she had 512. So Pillar had more. She had 512. How much more? We're going to subtract 512 inches cubed of popcorn. Subtract 480 inches cubed. It's 32 inches cubed more. So she had that much more. Persevere with problem solving. Remember the prism at the right. If all of the dimensions of the prism doubled, would the volume double? Explain your reasoning. All right, so what we're saying is that we're going to increase each side by a factor of 2. What would that do to the volume? Now remember, in our previous lessons, if we doubled the size of each side, what did that do to the perimeter? It doubled it. Okay? If we doubled the size of the side, what did that do to the area? Now remember, area is a squared unit, so that means it would be squared, so that would be times 4. Now let's say that we doubled each side. What would that do for volume? What's your guess? Now remember, volume is a cubed unit, so that means we're going to cube this. So that would be 2 times 2 times 2. So 2 times 2 is 4, and 4 times 2 is 8. So that means it would be 8 times more. So I'm going to write that over here. Our prediction is that it's going to be 8 times more because that's cubed. So let's see if that is the case. All right, so what are our current dimensions? Well, we have 3 by 3 by 3. Now, my numbers actually got deleted here, so I'm going to rewrite them. So the volume of the prism is what we're going to find out, but we need to double each side. But before we do that, since we're going to compare before and after, we have to figure out what the volume would be right now. So the volume would be 3 units times 3 units times 3 units. So the volume would equal 9 units times 3 units. So the volume would equal, oh sorry, this is squared, 27 units cubed. All right, now we're going to double, and I'm going to change my colors. So 3 times 2 equals 6. All right, so we have our new problem. The volume is going to be 6 units times 6 units times 6 units. So the volume equals 36 units squared times 6 units. So the volume equals 216 units cubed. All right, so now we have to figure out what is the relationship between 27 units and 216 units. So what you're going to do is 216 divided by 27. And if you do that on your calculator, you're going to get 8, which was what our prediction was. And up here, it disappeared, I apologize, but we had 8 as our prediction. Why? Because while we multiplied times 2, this is a cubed unit, length times width times height. So it would be 2 cubed, which equals a factor of 8. All right? No, the volume of the figure is 3 cubed, or 27 cubic units. If the dimensions doubled, the volume would be 6 cubed, or 216 cubic units, which is 8 times greater. Question 12. Justify conclusions. Which has a greater volume? A prism with a length of 5 inches, a width of 4 inches, and a height of 10 inches, or a prism with a length of 10 inches, a width of 5 inches, and a height of 4 inches. Justify your selection. So we have, for our first problem, we have 5 inches times 4 inches times 10 inches. And in our second prism, we have volume equals 10 inches, 5 inches, and 4 inches. As you can see, 5 inches, 5 inches, 4 inches, 4 inches, 10 inches, and 10 inches. Both of these have the same dimensions, so they're both going to have the same volume. The volume will equal 200 inches cubed. They both have the same volume. Volume of the first prism is 5 times 4 times 10, or 200 inches cubed. The volume of the second prism is 10 times 5 times 4, or 200 inches cubed. Question 13. Model with mathematics. Write a real-world problem in which you need to find the volume of a right rectangular prism. Solve your problem. Here is a sample answer. A gift box is 7 inches long, 9 inches wide, and 4 inches tall. So we could solve this problem. Well, here's our gift box. Okay, a little bow. So the volume, we're going to figure that out. It's 7 inches times 9 inches times 4 inches. So the volume equals 63 inches squared times 4 inches. So the volume equals 252 inches cubed. What is the volume of the gift box? 252 inches cubed.